The graph below is a graph of the function y equals sine 3x times cos 2x. Find p, q and r. Now this function is a product of trigonometric functions. It is a product of a sine and a cosine function. Now we have an identity for such a product. You can look this up. 2 sine a cos b is sine of the sum of the angles plus sine of the difference of the angles. So we can rewrite this product of sine and cos functions as a sum of sine functions. Well, first of all we have to divide by 2, but comparing we can see that a is 3x and b is 2x. So we sine 3x cos 2x equals half of this thing. Divide by 2. So we have a plus b, 3x plus 2x is 5x. And then we have a half sine a minus b, 3x minus 2x is 1x. Okay, let's look at the graphs of these in Geogebra. Let's look at the graph of a half sine 5x. So I'll do these two graphs separately and then I'll add them together. Now let's plug in the other function. That's a half sine x. Now we're going to add these two functions together. Notice that the range of both functions is the same. The range is just a number in front of sine. It's 0.5. Well, we get the range from that number. Well, in general, the range of a sine bx is minus a to a. So if a is a half, the range is minus a half to a half. It doesn't matter about b. B can be any value. The range is given by what's in front of the sine function. So the range of both these functions is the same. Now what about the period? Well, from a previous video we know that the period of a sine bx is 2 pi divided by b. So if b is 5, as it is for this function here, the period is 2 pi over 5. So for this function here b is 5, so the period is 2 pi divided by b, or 2 pi over 5. That's this interval here. It's the smallest interval over which a half sine 5x repeats itself. What about the period of a half sine x? Well, b is just 1 in this case. The coefficient of x is just 1. So the period is 2 pi divided by 1. So b is 1, as it is for this function here. The period is 2 pi divided by 1, which is 2 pi. And you can see that here. Period is this distance. So here's one cycle, or one period, of the function of half sine x. Now let's add these two functions together. You can see that for some values of x, two functions will reinforce each other. Like for example, if you take this value of x here, we'll be adding two positive values on, so we'll get some larger value. And at other points, the functions will be 0, so 0 plus 0 is 0 at this point. So the sum of these two functions will cross the x-axis at pi here, and they'll also cross at 2 pi. There may be points where the functions cancel each other out, maybe around here. See, one value will be positive and the other value will be negative, but they'll have the same magnitude, so they'll cancel each other out. So we might get 0 around here. We'll see cancelling here as well for values of x in around here. Anyway, I'll show the three graphs. So we can just enter in these two. We can just add them, or we can enter in the original function. Well, the way it was given, sine 3x cos 2x, that might be a bit quicker. So we're interested in points where the graph cuts the x-axis. So let's look at those points, P, Q and R. Well, P is this point here. Here's Q and R. So we skip these two. So these must be Q and R. As you can see, the shape of this graph isn't too accurate. But anyway, it cuts the x-axis at the correct locations. So to find P and Q and R, we just put this function here equal to 0. So we could just work with this. Of course, I've shown how it comes about. This graph comes about as the sum of two sine graphs. But to find P, Q and R, we can just set this equal to 0 and solve. It's probably easier than setting this thing say this form equal to 0. Why is this easier to solve? Because we have a product of quantities giving 0. And anytime you have a product of things that give 0, the only way you can get 0 is if one of them is 0. So that's the great advantage of using the product form when we're solving this equation. The other form involved the sum of sine functions. It's a bit more complicated. So straight away we can write down two equations from this. Sin 3x equals 0 or cos 2x equals 0. So from this complicated looking equation we get two simple trigonometric equations, and we've covered how to solve them in previous videos. Now of course there are several solutions to this equation. If you go to your calculator and get the inverse sine of 0, you'll get 0. So you'll have 3x equals 0. However, you can get another solution by using the cast rule. Okay, the coordinates of any point on the unit circle are given by cos theta sin theta. So the coordinates of this point are 1, 0. So this value here is actually the sine of 0, because the angle between this line and the positive x-axis is 0. Now the coordinates of this point over here are minus 1, 0. So this is the sine of some angle. The y value is the sine of an angle in the unit for a point on the unit circle, and in this case it's this angle here, 180 degrees. Of course we can do a full revolution and we can see that the sine of 0 is the same as the sine of 360 degrees, because 0 degrees is the same as 360 degrees when we're getting the sine, or the cos, or the tan. Anyway, let's get some solutions to this. Let's put 3x equal to 0. Well, if we put 3x equal to 0, we get x equals 0, which is this value here. We're not interested in that. If we put 3x equal to 180, we get x equals 180 divided by 3. That's 60 degrees. Now it could be this value or it could be p, we don't know yet. We need to look at this second equation. So let's solve this second equation. If you go to your calculator, get the inverse cos of 0, you'll get 90 degrees, or pi over 2 radians. Now there is another angle whose cos is 0, and that's 270. I've explained this in other videos. This point is coordinate 0, 1. This corresponds to an angle of 90 degrees. So this value here is the cos of 90, and this, if we take a point on the unit circle, here its coordinates are 0, minus 1. But it's the x value we're interested in. That's the cos of the angle, cos of theta. In this case theta is 270 degrees. So this is cos of 270 is also 0. And we can add another 180 onto that, or if you like 360 onto 90 degrees. I'll just write down another value in case we need it. So we could just add 90 onto 360. That's 450 degrees. That might be enough, hopefully. Okay, let's suppose 2x is 90 degrees. Well, then we get x equals 90 divided by 2 is 45 degrees. So you see the smallest value of x for which this graph cuts the x-axis is x equals 0. And the second smallest, as you can see, is not 60 degrees, it's actually 45 degrees. So this point here is 45 degrees. I can write that in radians. It's pi over 4 radians. Now, if we get a solution from putting 2x equal to 270, we get a value of 135 degrees. That's not the next smallest. The next smallest after 45 degrees is 60 degrees, so P must be 60 degrees. 60 degrees is pi over 3. Pi is 180. 180 divided by 3 is 60. Now, we have two more values that we're not interested in, but we need to get them out of the way before we can get Q and R. I better put 3x equal to 360 degrees here, because I think this is the next one. So 3x can be 0, 180 or 360. Divide this by 3, we get x equals 120. Yes, this is the next one up. So this is 120 degrees here. Now what's that in radians? Well, that's just 2 times 60 degrees, or 2 times pi over 3. I'm pretty sure that the next angle is 135 degrees. That's actually 3 times 45, and 45 is pi over 4, so this one here is 3 pi over 4. So now I'll go to the exact graph. We're at this value here. This is 3 pi over 4. You can see it's midway between pi over 2 and pi. It's a half pi and 1 pi is 3/4. Midway between them is 3/4 pi. Now we have to find R. Well, Q and R. Well, you can see from the diagram that Q is actually pi. And we have to go a little bit further with this here. If you think back to this, we can add 180 onto 0, and we won't change the sine function. The sine of 0 is 0, the sine of 180 is 0, the sine of 360 is 0. 180 plus 360 is 540. So if 3x equals 540, we see that x is 3 into 5 goes once, 1 over 3 4s are 12, 2 over 3 into 24, 3 8, it's 180. So that's what we saw in the picture. So that must be the next one up. That must be Q, 180 degrees. We can see it here, pi radians. So I'll write that in. So, you know, I didn't look at 2x equals 450 here. So x is 450 divided by 2. 225 degrees. Yeah, this is probably the next one. That must be R. Or maybe it comes from adding on another 180 here, but I doubt it. If we want to make sure that this is the next one up, the next value of x up that solves this equation, we can take the next value here by going to 720. So the sine of 0, 180, 360, 540 or 720 will give you 0. So I'm going up to another value now, 720. So if 3x is 720, what do we get for x? 3 into 7 goes twice, and 1 over, we get 240. Okay, so that must correspond to this one here. So R is actually 225 degrees. Now what's that in radians? Well, 225 is actually 5 times 45 degrees. So it's 5 times pi over 4. So R in radians is 5 pi over 4 radians. And this one here corresponds to 240 degrees. I'll just mark it in. 240 is 4 times 60 degrees. 60 degrees is pi over 3, so this is 4 pi over 3 radians. So P is pi over 3, Q is pi, R is 5 pi over 4. There's Q is pi, R is, this one here is 5 pi over 4. you can see that this is correct. This point is actually midway between pi and 3 pi over 2. So it's midway between 1 and 1.5 in units of pi. This is 1 1/4.